Assalamualaikum warahmatullahi wabarakatuh. So today we will continue with our next topic on chapter 3 for the bonding in coordination compound. Okay, so for the bonding in coordination compound, we will learn on the difference between the transition metal complex and representative metal complex. So based on the differences, the first one, transition metal complex usually have color, which is dependent on the type of ligand, whereas the representative metal complex are colorless. And the electronic configuration or the magnetic properties of the transition metal are affected by the ligand bonded to the central atom, whereas those of the representative metal do not. Okay, so for the bonding in complex, the bonding theory will attempt to account for the color and magnetic properties of the transition metal complex. So this is an example of various type of transition metal complex. So we have the first one is cobalt complex, nickel complex, the green color, and then we have a copper complex, copper 2 plus with a blue color, and zinc is actually colorless. Okay, so for the solution of nickel hexahydrate, so we have the first one, nickel. If the nickel is bonded to another type of ligand, will give a different color. And also if it is bonded to the Italian diamine, also will give a different kind of color. So for understanding the bonding in coordination compound, we need to learn on two type of theory. So the first one we call as a valence bond theory or VBT, and the second one is crystal field theory. So today we will cover on the first part, which is the VBT or the valence bond theory. Okay, so for the valence bond theory, it is a covalent bond formed between two atoms when an orbital on one atom will overlap with the orbital on another atom. So the total number of electrons on both orbitals is no more than 2. So if we draw the orbital box diagram, each orbital will occupy maximum number of electrons of 2. For the valence bond theory next, in transition metal complex, covalent bond are formed via overlap of a completely filled ligand orbital and a vacant hybrid orbital on metal ion. Okay, so the hybridization will determine the geometry of the molecule. So if the geometry is known, so the hybrid orbital of the metal ion used in the bonding is also known. Okay, so like what we have mentioned before, so for the bonding in complex, ordination in complex, so we have a valence bond theory that predict a metal complex bonding arise from the overlap of field ligand orbital with a vacant metal orbital. So it can be illustrated by this diagram. It can be explained by this illustration where we have a metal which is vacant, hybrid orbital, and we have a ligand which is filled with electron. So we will combine or overlap between the ligand orbital with the metal orbital, and this type of bonding we call as a coordinative covalent bonding. So it will result in the sharing of electron between metal and ligand. So for the bonding in complex, so this is the detail on the for the different. Okay, so this is the example of a coordination number with its geometry, hybrid orbital, and also some example for each hybrid orbital. So for the coordination number of 2, we have the geometry is linear and the hybrid orbital is sp. And for the coordination number of 4 and 4, we have two type of geometry here, which is the tetrahedral and also square planar, where the hybrid orbital is sp3 for the tetrahedral. Meanwhile, for the square planar is the sp2. For the coordination number of 6, we have one geometry but two hybrid orbitals. So we have d2 sp3 or sp3 d2. Okay, for the first example, for the first geometry, which is the tetrahedral. Okay, for the example, we will look on how to draw. Okay, so we have the first example on the Cl4 to minus, where the complex have a 3 unpacked electron, which is the electron configuration for cobalt 2 plus is 4s2, 4s2 and 3d 7. Okay, so for the cobalt 2 plus is 4s0 and 3d7 lah, because we have lost 2 electron in the formation of complex with the 4 Cl ligand. So this complex is paramagnetic. So how can we determine the paramagnetic properties of this complex? So based on this orbital box diagram, so we need to draw first the orbital box diagram. So for the orbital box diagram, at first we have to draw for the cobalt ion without the formation of the ligand. So we will draw the argon, okay, the inner electron, and 3d7 for S is 0 and for P is also 0. And then for the second one, we will draw the cobalt complex with the addition of the 4 Cl ligand. So each Cl ligand will carry 2 electron to form a bonding with the cobalt metal. So if we have a 4 Cl ligand, so we will have a 4 bonding. Okay, so for this 4 bonding, we will we will determine the hybridization for this cobalt complex is as P1, P2, and P3. So S1, P3. So the hybridization is sp3. So if we refer to the table before, if we have a hybrid orbital of sp3, so the geometry is tetrahedral. Okay. Sorry. Okay, so the next one, I will continue with the next video.